Chris Goddard is going to introduce the seasonal forecast related workflows and tutorials and where to access them. So I hand the floor to Chris.
Yeah, thanks, Chris. Hopefully you can all see my screen okay and the pointer.
Yeah, we can see it fine.
Great, thank you. Yeah, so I can be quite brief here because a lot of this will be recapped this afternoon as I go through some of this in more detail in the demonstration. So here I'm going to talk about, so we've heard about accessing the data and the graphical product. So here I'm going to talk about how you can start interacting with the data itself and possibly reproducing some of the graphical products, the verification, or customizing this for your own purposes, and where you'll be able to possibly run that on cloud service provider platforms, and some tools available to help with this. So the first thing I'm going to mention are the C3S data tutorials. There's going to be a lot of links here, so I will rely on my colleagues to possibly put some of them in the chat, but I'm sure also the slides will be available afterwards for you to access these links. So here I'm going to mention Jupyter Books and Jupyter Notebooks interchangeably, probably, but yeah, as you probably know, a Jupyter Notebook is a way of making code available with some markup around it to explain what's being done and to also share the results of running the code. And then when I say a Jupyter book, that's essentially just a collection of Jupyter notebooks with some HTML formatting around it, which essentially turns it into a website. And so the first one of these I'm going to mention are the C3S data tutorials, which are available as a HTML Jupyter book at this link, which may change in the future as they're being upgraded at the moment. But for now, this is currently the link to use. You can see here on the left a screenshot of this Jupyter book, and you'll notice that on the left, very left, there are a long list, probably with too small text to read, but a long list of different examples for different types of data sets. So most relevant for this audience, we have one tutorial specifically on producing seasonal forecast anomalies, another on verification, which reproduces some of the verification charts that Edu was talking about earlier. And then there is also one on bias correction more generally, using an Abacus package, which was produced for C3S. And that could also be applied to seasonal forecast data, of course, with due care in selecting the correct reference data set and the correct method of bias correction for your application. These C3S data tutorials come pre-installed on the CDS Jupyter Hub, which I'm going to mention more about later. And I'll now mention one example, which I will be running through after lunch, and that is the example on verification. So here on the left, we have that verification page Edu mentioned with these static plots, which you can browse by selecting different options in these drop-down menus. That's available at the link here. With the data sets which Edu has been running us through, as well as the code available in this training notebook, which you can download by clicking the download button on the corresponding page in the Jupyter book. You could then actually reproduce these yourselves for different variables or different, if you wanted to download multiple systems, you could make combinations and then verify those. Or aggregate the data in different ways, and of course select subregions. So these ingredients are available for you to reproduce these verification plots yourselves. On these, so further examples, there's another Jupyter book which we're currently still preparing, but it is already available in sort of a draft state. So that's available at the link here, also sitting in the ECMWF projects, the GitHub repository. So here, these kind of complement the tutorials by going into a bit more detail. So they're not as user-friendly. They don't necessarily have as much text surrounding the code, running you through it. And they're also more resource intensive in terms of the data downloaded possibly and the processing done. But the aim here is to share some workflows which are related to the graphical product, allowing you to reproduce them. But also to potentially share some additional analysis and things which are not made available as graphical products, so potentially some experimental products or alternative views on things. Here we have, currently we have an example on reproducing the gridded graphical product, so those maps that Edu has just been showing, so ensemble mean anomalies as well as tercile categories. Reproducing the ENSO indices, which Edu also showed, as well as then verifying those ENSO indices by producing correlation heat maps, where you'll essentially have the correlation values as a function of start and lead time, color-coded based on the numerical value. There are some more ECMWF examples like this, so different Jupyter books with different pieces of code that you may find useful depending on your area of work. So the C3S Climate Atlas, the Interactive Climate Atlas, there's a Jupyter book which makes available the code behind the atlas, so both the calculation of the indices as well as the production of the plots. There's also a similar notebook, set of notebooks available for the C3S climate monitoring, which you may see come out every month. So that's also reproducible via those. And there's also something called the ClimAX project, which is about regional climate risk assessment. And ECMWF is involved in producing the Jupyter book, which makes available all of those workflows and case studies. So back to the seasonal forecast specifically. So yeah, as I mentioned, there's an example about recreating the graphical products. So we have that screenshot on the left that Edu has been running us through. So using the data which is available and the ingredients in these notebooks, this essentially allows you to reproduce those graphical products and customize them again as you see fit. The final set of Jupyter resources I wanted to mention come out of the C3S EQC activity. So this is an external evaluation and quality control function of C3S. You'll notice there's a quality tab. You might have seen it when Edu was quickly showing us the CDS. There's a quality tab there. And linked from that is a collection of Jupyter notebooks, which are essentially example quality assessments in the context of different use cases. And there are a few available for seasonal forecasts, and more coming soon. So these look at things, sometimes they're more almost like a tutorial where it shows you how to deal with having a multi-model or multi-system probabilistic forecasts. There's an example on looking at the biases that are present in seasonal forecast systems, and also an example on one view of forecast quality, looking at the hit rate for tercile categories. I have a couple of examples here showing you what those look like, but I'll just skim through them in the interest of time. So I have some example plots which are produced in these notebooks on the right. And here is the example for looking at biases in the systems as a function of start month and valid month for different predefined regions. So to mention here, the code is also available behind these notebooks, but it's less user-friendly because it's really just there for transparency, and the code is designed to be running as efficiently as possible on the infrastructure that these EQC evaluators are doing their evaluations on. So then not necessarily as user-friendly, but the explanations are there and the plots are there. So they may still be useful to you. So now I'll quickly mention one possibility for running these kind of notebooks, and that's a new service from C3S, which is the data store Jupyter Hub. It's available at this link here, jupyterhub.ecmwf.int, and then you need to select in a drop-down menu, which you'll see ECMWF Data Store Service. To do this, you need an ECMWF account and to have logged into the CDS. And there is some documentation available on Confluence about this service as well, which is currently in experimental or beta status. That doesn't have a very user-friendly URL, but I'm sure that will be made available. Well, the slides will be available afterwards. So essentially, this gives you a limited resource. It's only 4 gigabytes of RAM currently, but a limited resource to run these kind of notebooks I've just been talking about directly on C3S infrastructure. There are also a few other cloud platforms available that we kind of recommend. So in the tutorial, in the C3S tutorials Jupyter book, we have direct links to launch Binder, Kaggle, or Colab, which are 3 different cloud computing services. And if you're on a specific notebook and you click one of these buttons, it will actually directly open that notebook on that platform. But another option is to, if you, for example, find some code elsewhere that doesn't have these direct links, you can download the Jupyter notebook and then upload it to one of these services. Finally, there's also the Wekio platform, which is a Copernicus initiative. And that's a wide Copernicus initiative. So it's not just about C3S data, it's actually more focused on satellite and other Earth system, Earth observation data. But that again can be used to provide free compute, limited but free compute in the cloud platform without downloading anything on your own machines. The last thing to mention is EarthKit. So this is another ECMWF wide initiative, but also relevant to C3S. So this is a Python-based data analysis and plotting toolkit. It has many components, which you can see listed here on the left, to do with manipulating data, different packages of index calculation and analysis relevant to, say, hydrology, as well as functions like regridding, time manipulation, and aggregation. And there's documentation available here. It's still a service that's evolving quite rapidly. So some of these packages are developing on a weekly basis. The power of this is that it's kind of provides a data format agnostic way to interact with this data. So you can see here that in 3 lines, you import EarthKit, you produce a data object, which is actually a CDS request, but you don't need to actually make the request separately, download the data and reload it. That's all done under the hood, and then you can directly plot this data. So this is something that you may also be interested to look into, and in the coming months and years, C3S example workflows and tutorials will certainly start to make more use of these EarthKit packages. So I think, yeah, that's all I need to say now. To let us move on to Franco's presentation, and in the session after lunch, I'll be diving into this in a little bit more detail. Happy to answer any questions, I guess, in the chat, in the interest of time.
Great. Thanks a lot, Chris. That was, I think that was really useful to see a list of all of those links. I've tried to put as many of them as possible in the chat, so you have them, but also you can refer back to the presentation and get them from there as well. In terms of questions, I think the questions posted in the chat have already been answered by Anka, which is great. Would anyone like to just, are there any other questions, or anyone wishes to raise a hand just to ask a brief question now?